Okay, let's look at amines to carboxylic acids. This is hydrolysis. And we're making carboxylic acid, so we're going to be doing an amide to something with an OH group on the other end. And they call this hydrolysis. So we're going to do it in acidic conditions, and then we can do it in basic conditions. You can do it in both. And so let's start with what we have in solution. We've got H3O plus as our acid, and we've got plenty of water because remember that all of this is going to be in water. And so we're going to use that water a lot, actually. Now, the first thing that's going to happen here is we're in acidic conditions, so you got to automatically think, what can I protonate? Well, I've got these lone pairs on this oxygen, and they can be protonated. So let's give that, and let's put our electrons back on oxygen. Now we've got, we'll still have that R group, we've got our NH2, it has a lone pair, and we still have a lone pair here, and we have a hydrogen now. And so remembering our charges, we have 1, 2, 3, 4, 5. We need to put a positive charge on this atom here. Now, we have H2O in solution. And what we're going to do with that, it has protons on it, or electrons on it, lone pairs, is we're going to get rid of this negative charge and positive charge on the oxygen by attacking that carbonyl carbon with our water molecule and kicking these electrons off. And this water molecule is going to act as our nucleophile. And we just created some when we took off the hydrogen from our acid. So we're in good shape. And so now we're going to get this R group here. We still have our NH2. And now we have H2O. And we have an OH group up there. Now, make sure you get your charges. This, since it's a water molecule, it should have a positive charge, just like in the last situation we saw. And now we want to get rid of the nitrogen group because we're trying to make a carboxylic acid. So our thought process here is to remember what we're trying to make. We're trying to go from this to a carboxylic acid. So in effect, we're trying to get rid of this and replace it with OH. And so we've added our water, which is going to be where our OH comes from, and we need to get rid of this nitrogen group. And we're in acid. So right now our nitrogen group is neutrally charged, and so it has a lone pair that it can take a hydrogen and get protonated to become a positively charged thing, which can exist in our acidic solution, remembering that positive stuff is good in acid. So let's just assume, for simplicity, that this nitrogen lone pair steals this hydrogen from this oxygen, this water molecule, because we want to neutralize this anyway. And so that makes it pretty easy to do. And we'll get this OH still up here. We've got our R group. I'm just redrawing the molecule. We've got NH. Now we've added a hydrogen, so we've got NH3. We do not have a lone pair anymore, and this has a positive charge. And we still have our O, just H, because we took a proton off of it and we added it to the nitrogen group. Well, now our nitrogen is good to leave. It's fine to leave. And so we can take another water molecule and we can actually rip off a hydrogen from this OH group, sending these electrons back to this double bond and kicking off this nitrogen. Oh, I'll check. Give me 1 minute. Okay, so now what we're going to do is follow our arrows and see what we've formed. So we've got an R, we've got an O, we've made a double bond back to that O. We still have our OH group here, and we've removed an NH3. And we've reformed our H3O plus. And so these, in theory, are an acid and a base, and you would definitely have a reaction going on there. But we've formed the product that we wanted, and that's this, our carboxylic acid.